This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Welcome, everyone, to the Sunday night FRC Roundtable. My name is Scott Davis. I'm a mentor with Team 2052 Nightcrawler. Before we get started here, we have a few housekeeping notes. The FRC Roundtable is recorded for YouTube and Spotify. We ask that you be 13 years or older to participate on the live call. If you are comfortable, we ask you to please have your cameras on when you're speaking. The Roundtable is no longer exclusive to Minnesota teams. We encourage mentors and students from all FRC teams to join us for the live call and watch us on YouTube and listen to us on our podcast platform across Spotify, Audible, iTunes. I think we're on all of them at this point. And for more information, including our complete privacy policy, we encourage you to visit team2052.com/roundtable, and you can read all about the Roundtable and find all of our past recordings and podcast links. We like to start off the episode each week with a segment we call What's on the Wiki. And if I can get my share up here, here it is. Tonight's What's on the Wiki is all about captains and leadership. So every year about this time, we start thinking about selecting our captains for the next year. I don't know how many teams out there that are on the call tonight are doing captain selection in the spring, or if you're doing that later in the year, in the fall. But we do our captain selection in the spring. And if you're interested to know what our captain selection looks like, we have a fair bit of information on our wiki. This is the information that we point all of our students to. So there's some general overview stuff. We have a bunch of sample interview questions that we ask the students for each role. We have a breakdown of the leadership roles, captain roles, but also leader roles that we have on the team. And then we have an example of a rubric that we use. We have all students on the team evaluate all student candidates based on our core values. So how well do they exhibit gracious professionalism, dedication, growth, structure, and unflappability? And so we survey all the students. This is sort of their opportunity to quote unquote vote. We don't have a pure vote for captains, but this is how we get student impact or feedback in terms of what they think about the candidates that are up for captainship and leadership roles on our team. So maybe this will help you improve your process. And if you have thoughts on what we're doing and you want to share that, you can always send us an email too at info@team2052.com. All right, let me stop my share and stop that. There we go. All right, tonight's presentation is from Luke, who's from 2530 Inconceivable. Luke's going to talk to us about electronics. I'm not going to take any more away from you, Luke. Please introduce yourself, give us a rundown of your presentation, and the floor is yours.
Can everyone see that?
Yep, looks great.
I started presenting. All right. Hello, everyone. My name is Luke Hunter-Holzner. I'm here today to tell you a little bit about some of the things we do to make our wiring more reliable on Team 2530. I'm also going to be talking about a few ideas for how wiring with the system core is going to be looking in 2027, or late 2026, early 2027. Just a little bit about me. This is my fourth year on Team 2530 and my last year. I've been the driver for 3 years. This year I'm a captain, and I've been our electronics lead for 2.5 years now. Next year, you'll see me over at UW-Madison, getting my mechanical engineering degree and consuming copious amounts of dairy. About this presentation, if at any point you'd like to share something, whether it's a question, electronic experience, other statement, you can raise your hand in the Google Meet, or just straight up interrupt me. I'm okay with that at a natural point in the presentation. Or you can also type it into chat. Supposedly, I will see that show up And then afterwards, if you'd like to go back to any of these slides, and there is a status light inspection chart for you to take home, that will be posted on Chief Delphi following the meeting. To start off, I'm just going to talk a little bit about some things that are not related to the Limelight System Core that I still think are important to share. And the first one I would say is how we route our wires. This can mostly be summed up by the tools we use to route our wires. It's a lot of zip ties, sticky zip tie mounts, double-sided sticky tape, and I'll just talk a little bit about those. As far as zip ties are concerned, something I would absolutely look into would be flush zip ties. Reasoning behind that is they create less of a sharp point when cut, and they're a little smoother to work with. They make a nice circle to really hug all the wires without any of the sharp points that a regular 90-degree zip tie would use. You also see lots of sticky zip tie mounts around our robot. Some people have said there's too much. There's a bunch on there that don't even get used. It just makes sure that everything stays exactly where you need it to be. In general, with our robot, anytime something is able to move, I assume that it will break at some point. So many of those it's almost always better. There's a little bit of weight consumption there, but I would say it's well worth the benefits of that. Anything with 3M on the back is honestly going to work for you. There's all kinds of sizes and different shapes, and some have different features, but definitely give those a shot. To attach most of our electronics components, we use foam double-sided sticky tape. We don't really screw anything in too much unless we really need to, or zip tie things down. Usually just a really good double-sided sticky tape is enough to hold our things down for us and just keep things from going where they shouldn't. Also helps out a little bit with vibration, but that's besides the point. Some of the other tools you'll see us use a lot, energy chain and cable bundling. In the past, this slideshow has said that energy chain is for moving wire linearly, though we found a different way to use that this year. If you've had a chance to stop by our pit, you may have seen our cable management for our turret that uses energy chain. Some things we found with energy chain that cause a lot of issues is if it's too full or if there's not strain relief on each end. This is kind of hard to notice when it's moving super quickly, but the wire is moving throughout the cable chain as it rolls back and forth. And if it's too tight, that creates a lot of friction or needed force, and that can cause damage. Also, cable bundling. This can be used in tons of spots. Generally, anywhere that a wire is like on the outside of our robot or really exposed, we're going to have a cable bundle there to protect that from being grabbed. Main thing with that is just to fuse ends and just get a bunch of sizes of it. Honestly, just have that like you have like electrical tape and hot glue. Super useful to keep everything in place. And then the last thing that I would talk about as far as routing is concerned is just using hot glue and electrical tape. A lot of people kind of write them off as cheater solutions, but I think they have a place on every robot, whether you're just gluing things in to make sure they come out or covering things to make sure that nothing gets into a spot where it shouldn't be. Possibilities are only limited by your imagination with hot glue. So the practicality is sometimes lacking, but yeah. And now we're going to talk about the Limelight System Core. Everything in this presentation now is pretty much going to be talking about wiring this or in relation to how this changes FRC wiring and how that's going to work. I'm going to start off by just talking about kind of what you see on board. As best I can tell, what you're seeing now is the most updated drawing of what the Limelight System Core is going to look like, powered by Raspberry Pi, of course. And so I'll just jump into it. In the upper left, that's your power. That is going to be a Weidmuller port this year. Weidmuller, if you haven't seen them, they're on the Limelight 4. They're on the Robo Rio. Basically, you push a button, put a wire into those two holes, and let go of the button to clamp it down. Much like a Wago, except instead of opening and closing a lever, you push and release a button. When I first saw Weidmuller, I tried to shove a ferrule straight in there, and it did work, but I would not recommend that. That can cause some issues. Over to the right of that, we have the hot glue receptacle, also known as the bridge port. That's mainly for FTC. They're also going to be using the Limelight System Core, and that connects to the device that powers most of their motors. I believe 2 of those pins are powered. I'm not entirely sure. Don't need to know. Just probably cover that and don't ask questions. To the right of that, of course, we have the Link USB-C, and to the right of those is the most beautiful thing about this robot controller: 5 amazing wide-muellered CAN bus ports. We'll talk a little bit more about the ramifications of that here in a minute. But everything else, you got your RJ45, you've got your USB-A, and then Molex SL connectors, which we'll talk about here in a minute. In relation to the Limelight system core, I'm just going to talk about connectors kind of in general, but then also more specifically, I'm going to talk a little bit about those Molex SL connectors, which are kind of finicky, but really powerful if used correctly. I'm going to mention wire gauge here in a minute. So I'm just going to remind everyone that a big number is going to mean a small wire. If you think about 22 gauge CAN wire, very tiny. If you think about 10 gauge Kraken wire, that's going to be very big. Here's some of the connectors that we're familiar with that work well. I'm just going to kind of talk about them briefly and what they can be used for. Number 1 on the list is going to be Wagos. If you're a new team, or you don't really like wiring, or you don't find it that fun or enjoyable, Wagos are a totally great solution. Every single wire on a robot can be, like with this kind of Wago, the Wago 221-4 or the Wago 221-6, you can wire your entire robot with just those. So if you don't want to try anything weird, you don't want to have to learn how to make any connectors or get any specialized equipment other than a stripper and a cutter, Wagos are a great solution. The one you'll mainly see, the Wago 221-4, that can accommodate 12 gauge wire all the way up to 22 gauge wire. So that's CAN and like the typical motor wire. The only thing that these cannot accommodate is going to be a 10 gauge wire. If you really want to continue to use Wagos for those, though, you can buy a 221-6, and those are just like a little bit bigger, and they can get 10 gauge wire. So if you wanted to, you could wire your robot entirely with those. It's a totally acceptable solution. Next on that list is crimped terminals. These are the Molex SL connectors you'll see on the Limelight, on the system core. We need to come up with a shorter way to say that, so I'm just going to call it the core. These are great. They have a little clip to keep them from coming out. We use them in 2025 for our CAN wire. I actually have one here, and the receptacle on the system core is just the same one you would use just to hold a CAN wire together. This works fantastically. We stopped using it because our wire was too thick for the connector itself. So, but definitely, depending on the wire you use, if you're willing to invest the time and the practice to getting these set up, they can be a really powerful asset for making your robot easy to wire and very plug and play. But just the thickness of the wire we use made that not really a doable thing. Something we wanted to try out this year was the solder seal wire connector. These are not going to come out. The way it works is you strip the ends of each wire, you put them inside this tube, and then you get it really hot, and some solder in the middle melts, bonding those wires together. It's really strong, but again, you would have to cut it to get that off. So we've ended up not using them this year just because our robot is so compact that if we wanted to get in there and cut anything or repair anything, it's not as easy in 2025 where we just had a big arm out in the middle of everything. We can't get a heat gun into most parts of our robot. So, but they have found a good place in my heart as a tool to repair wires that are damaged. 2 more Anderson power poles. We haven't used these as long as I've been on the team. It sounds like they're a little bit of work to set up, but they're basically the Molex SL connector of thicker power wires. So if you look with Anderson power poles and Molex SL connectors, you could crimp everything the moment you take it out of the box and be done. Minus the connecting wires to get to your PDH and CAN or whatever you need. There's also the Wago 222. It's still good. I'd say the other one, the first one you saw, is a little bit better. We're actually using Wago 222s this year for our CAN wire. So, I mean, they're almost as good an option as the 221. You lose a little bit of inspectability with those. If you look at the Wago 221, there's a little hole in the top of it. I can even put my cursor on there. There's a little hole there that allows you to stick a multimeter probe into there, so you can just test if there's current running through it or do whatever you need to do without ever needing to really like take any wires out or anything. So that's why they're a little bit better. There are no wrong connectors. However you get your wires together, whether that means like a tube of heat shrink and solder and a soldering iron, if that works for you, go ahead and do it. Those are some of the ones that you're going to see more commonly. I just thought I'd mention those, talk about what we use and why. I've touched on this. For our wire, we use high strand count silicone wire. So rather than one big piece of copper in the middle of the wire, there's just a whole bunch of tinier pieces. And the outer casing of the wire is a nice and flexible silicone. This has been hugely helpful for things like cable chains and some of the tighter routing we do. It prevents things from getting bent, kinked, breaking. But it is an issue with it is it can get cut. The silicone is not very durable, so it can just get slashed and exposed. And that's not so great. So that's a downside to it. So you definitely have to be careful to keep it away from sharp things, but it's what we've ended up using. And then again, you can't use the Mole XSL connectors with silicone can wire because, again, the silicone part of it is much thicker than the connector can accommodate. Whatever connector we use, whether it's ones between wires, like Wagos, Anderson Power Poles, Mole XSL, or even just the ones actually attached to our components on the PDH, in the RoboRio, just on anything. We always look at the associated documentation with that component before we wire it. This is a huge thing I would recommend. It's really helpful. I mean, it might just mean watching a YouTube video on how to do it. Sometimes it's figuring out a specific strip length for something like the PDH. That's always worth doing. Just go and figure out what the exact numbers are. Sometimes you hold a ruler up to a wire, like for those big ports on the PDH, we measure those down to the 1/10 of an inch if we need to. And then lots of practice in time. Depending on what connectors you use, it might not be so intuitive. Sometimes you have to get really personal with it to get everything to go into place and to work well. So, but definitely if you're going to do something like a Mole XSL connector or an Anderson Power Pole, learn, practice. Yes, the connector costs a lot, but so does the price of going to a regional. So get every cent out of that you can and spend your time figuring out how to do whatever you want to do correctly. A big thing, we never like to place a connector anywhere that will experience strain, and we like to keep our wire in as continuous of a run as possible. So if you look inside a cable bundle or an energy chain, anything that moves, there's not going to be a connector in there. Just keeps things from getting pulled out. It doesn't matter how bad your connector is. If it doesn't move, it's unlikely anything is going to happen to it. Right. This is the part of the Limelight system core that I'm most excited about from a wiring perspective, and I hope I can get you very excited about it as well here in the next few slides. CAN. Again, 5 CAN ports, that opens you up to 5 CAN buses. To understand exactly what that means, I'm going to quickly just show the basic how CAN works on regular robots. Basically, it starts at the scary programmer square, RoboRio, Limelight system core, whatever it is. It runs to each device. So there's one big line going all the way from the start of the robot to the end, and it ends at a 120 ohm resistor. It does not always end at the PDH. The PDH has a resistor built in, which you can turn on and off, and that has some helpful benefits to it for debugging, but it does not end at the PDH necessarily. It just ends at a 120 ohm resistor, and with 5 CAN buses, you're going to be hard pressed to have 5 of them end at a PDH. Again, this is what it looks like to just have it like manually terminated with your own resistor. There's just a little switch on the PDH that lets you do that. Just some things with CAN wire, and the reason I'm going to drill this again is because it's really important to get CAN correct this year, or with the Limelight system core, if you can have multiple lines. The fact that CAN wire is twisted is really important. I've seen on like some instances of very wide branching CAN, and that opens it up to electromagnetic interference, which can decrease the capacity or straight up kill your CAN bus without you even necessarily realizing what's going on. So keep it twisted, definitely a good idea. Try and keep it away from electromagnetic things, magnets, pieces of metal with motors attached. Try and keep it away from that can interfere with it. And tip number 3 on that slide is going to be less relevant this year because having 5 CAN buses does it anyway, but you can use the PDH to quickly debug things. By turning it on and off, you can figure out which side of the CAN bus is damaged. Again, not going to matter with the Limelight system core, but it's still nice to know that that's an option. And it's good to just carry around a 120 ohm resistor specifically for debugging, though again, you're going to have more of those if you have multiple CAN lines. The third kind of extension of this is something called CAN FD, which most people aren't going to be super familiar with. Basically, before the Limelight system core, if you wanted a second CAN bus, you had to purchase a device called a Canivore, plug it into a USB port on your Robo Rio, and that would create a second bus called a CAN FD bus. The difference between a CAN FD bus and a CAN 2.0 bus, which is what the Robo Rio typically does, CAN FD is much faster. It can send a lot more information through the same wire, and it only works with CTRE devices. So you have to think about that. If you have an all CTRE drivetrain, so Kraken X44s, Kraken X60s, you could use a CAN FD bus there if you wanted more information to go through. I would not spend $300 on a Canivore now because you're probably not going to be needing one next year. So when you're wiring CAN with the new system core, again, instead of having one CAN line, you're going to have 5. And at first glance, you would think, oh, great, that's going to make our robot much more reliable. I would make the argument you're going to have the same number of issues, but the issues are going to be less bad and harder to identify, depending on how you do things. I've divided this into 3 kind of areas of benefit. The first one is debugging. This is, I think, one of the places that the system core is really going to shine, is to figure out where things are broken. First off, if one of them breaks, you instantly know which group of devices are faulty, like where the break in the CAN is. There's also CAN accessibility. So if you have a wire that's running through an inaccessible part of your robot, there's a higher likelihood you don't have to look for damage on that wire. If for example, the damage is just on a different CAN bus or somewhere else, you can say, oh, I don't even have to touch that wire. We'll talk about that in a minute. I can just fix the other parts. The downside to having multiple CAN buses is going to be that it's going to be more difficult to identify a CAN failure unless you're specifically looking for it. Up till now, if you wanted to identify that your CAN line was working, you'd turn your robot on, and everyone has their favorite component. I would just look at a CAN coder and see that it was blinking bright green and say, oh, all is good in the world. You can't do that if you have 5 CAN buses. You'll have to check each and every one to make sure it's all happy and working well. The second benefit you can get from having multiple CAN buses is going to be partitioning. So if one part of the robot fails, everything else on a different CAN bus is still going to work. I'll give an example of that in a minute. The key thing with this is normally if a part of your CAN line breaks, your whole robot's just dead. You kind of don't really care what it does. You've probably noticed that it just kind of slumps over and dies. But specifically, if you're going to think, okay, if this part of the robot breaks, what do we do? It's important to understand that every motor connected to that CAN bus will by default enter coast mode. So, for example, in 2025 with the Shrieking Eel, we had an arm, and we were thinking about adding a CAN FD bus to the robot for our base, so if our arm broke, we could still drive. But we figured it wasn't really worth it for us because our arm would actually slump over and be outside the robot. And our manipulator was held on with one screw. So we were thinking, well, we wouldn't really want to drive that much. We wouldn't really want to play defense or shove anything. All we'd really do is climb. So maybe it's not worth it to spend the time to install a CAN FD bus. So just as you're going through and creating your CAN wires, just keep in mind, it will enter coast mode if any of those dies. All those motors will just have neutral output, no power. And then the third benefit is data. With 5 buses, you're going to have much more capacity for data. And you also have the capability to set any given CAN bus to be a CAN FD bus. So say if you had a drive base that was all CTRE devices, you could have a CAN FD bus with much more information throughput that only uses CTRE devices. I don't know why you'd need to do that yet, because you have 5 CAN buses and therefore 5 times the information throughput. But this might lead to a change in how much data is being sent through a CAN line now that there's more options. So keep in mind that the CAN FD option exists, or should exist, still susceptible to change. Looking at our robot from this year, Dread Pirate Loberts, or unformally known as Loberts, here's what that partition would look like for us, or here's how we'd separate our CAN bus. We'd probably have one of those CAN buses go straight to our turret. That's kind of like the obvious pick. If it has to run through all this energy chain out onto our turret, this big moving part, if any of that breaks anywhere, right now, we can't drive. We're just dead on the field. But if that was its own CAN bus, we could still drive, do defense, push fuel, intake, spit balls out of our intake, move things around, potentially even try and diagnose and fix the turret issue as we're going. But that's just only an option we have by having a separate CAN bus for our turret. The other CAN bus we'd probably have, or the second one I would say, would be our battery bay. If you look at our robot, right above the Team 2530 number on the bumper, 2530, there's a little hole there. That's actually where we put our battery, and there's lots of wires, including CAN wires there, which tend to receive just kind of abuse and damage as we're shoving batteries into there. So having that be its own sector of CAN could be a great way to quickly identify that, oh yes, this region where we're constantly shoving our batteries in our hands and getting in there with a moving chain in there, that's the issue. I don't need to look at the rest of the robot. I just need to look at this one high-risk area. So isolating a high-risk area so we can debug it, our battery bay would be a good example of that. If you look at the lower right photo, I'm not sure how well you can see it, but there's 2 2x1 box tubes sandwiched by polycarb. And right now we have a ton of power wires and CAN wires that can only get from one side of the robot to the other by running through that channel. Ideally, we never have to inspect that channel for CAN damage. So likely, we'd make it its own CAN line. In the devices on that side, we'd only want 2 of them. We wouldn't want much to be happening over there. So we never have to get to that inaccessible part of the robot. Whereas if there's an issue that it's hard for you to detect, and you have to inspect the whole robot for wiring, you might decide, oh, hey, we have to tear apart our robot to get into that tunnel, rather than just saying, oh, hey, that's not the issue at all. So using it to never have to inspect an inaccessible part of your CAN wire, unless you really need to, is another benefit. And then finally, just to sector things off more so we don't have to debug as much at once if something breaks, we just have on the side of our robot where our system core is, we'd have all our devices connected on their own bus. And so this leads me into a thing I talked about earlier. Before, if you wanted to figure out if your CAN bus was working, you look at just a single light on the robot somewhere that indicates that CAN is working and all is good. Well, no more. You're going to have to look at multiple components to figure out what works and what doesn't, and ensure that each and every single bus is working correctly. To do this is probably something you should do between matches. I'm sure there will be teams who have a CAN breakage in one match and don't realize it until they're in their next match. So between matches, you're going to want to make sure every bus is working. Again, before you could just turn your robot on, look at one light, call it a day. Now you have to do a bunch of inspection. And not everything may have a CAN coder on it, which is my favorite component to check for CAN errors. So having a sheet like this, or just teaching each member one device to look at on each CAN bus is going to be important. This is what I'll post on Chief Delphi. Just a few cool things to kind of note with this. The VH109 radio. I have not seen a lot of people that know what all these lights do. So just going from top down, when it's working properly, the power light should be solid. The status light should be off. And the 2.4 gigahertz light should also be off, unless you're using that to connect to your robot over Wi-Fi. Most teams are using a second VH109 to connect to their robot. So if that middle light's on, you can just flip a switch on the back and turn it off because you don't need it anymore. The most important light to look at is going to be the only blue light on the VH109. That's the 6 gigahertz light. That will turn solid blue when it's connected to another radio or a driver station or something like that. So just look for that to be on. And the robot light, this is documented nowhere. There are a few CSAs that didn't know this. It just does the same thing as the Ethernet port to the RoboRio. So it should just be blinking crazily. I've stared at that a bunch this year. I'm like, why isn't it solid? Why isn't it solid? What's wrong? No, it's supposed to be blinking crazily. So don't write off the lights on your radio. They're telling you stuff. And then another thing is, this is an issue you probably won't experience, but camcorder lights, there's a difference between bright green blinking and dim green blinking. So just be aware of that as you're going through. A little bit more is written about it on this cheat sheet if you want to take a look at it, but turning your robot off and on is going to be helpful when looking at a camcorder. That was pretty much everything about the Limelight system core I wanted to talk about. And so I'm just going to share some final tips. Overall, these are just quick things you can do, not super hard, not super difficult, but they can prevent some truly nasty failures from occurring. First one, just cover all your exposed ports. This is a big thing on the RoboRio. I've never tested it, but I have been told that if a certain 2 pins touch each other, no more RoboRio for you. I'm not sure if the system core has the same issues. I assume that would be fixed, but you don't have to worry about it if you just cover the ports. I would recommend just taking like a connector. If you crimp your own Ethernet cables or you decide to make your own Molex SL connectors, just put a blank one of those connectors in the port, plug it in, nothing's getting in there. Super helpful. Yeah, just don't leave it to chance to cover them up. Second thing, hot glue. This is definitely underrated. A lot of people, I've found myself in the same spot where you're thinking, oh, that Ethernet wire is so far inside the robot, how would it ever come out? Nowadays we know to hot glue it in anyway, but the truth is there's all kinds of things that can make it come out. Other wires moving around, someone sticking their hand in there to grab something or inspect something. Hot glue will save the day for you. So hot glue all your connectors in. Certainly underrated. It's not that hard to get out. I know it's like, oh, it's glue. If it's attached to a smooth surface, you can pry it right off with a little bit of leverage, but wire's not going to be able to do that. And then the third thing I'm going to say, it involves a little bit of math. There should not be that many exposed wires on the exterior robot. Make it as few as possible. The way I like to think about this is the total amount of time in a year you'll spend fixing wiring damage is equivalent to if you had an angry monkey in a room with your robot over the course of an alliance selection. So think how damaged would your robot's wiring be after that alliance selection? And that's about the amount of time you'll have to spend fixing it. So if the answer is the monkey wouldn't be able to do anything, you're in a good spot. That was pretty quick. That was kind of most of the stuff I had to go over. Of course, if you have questions or things you'd like to share, my Discord is on there. So is my email. If you give a smoke signal, I might be on the lookout for it. I always respond to those promptly. So yeah. If there are no immediate questions someone has, I have some questions that I could ask the group, because I'm curious to hear from the people.
Jesse's got a question. Go ahead, Jesse.
Okay.
I got a question for you, Luke. This year we used the Swift CAN Connect wiring stuff.
Go
ahead, give me your opinion on it.
Yeah, I don't know much about it. I think it's very cool. I've seen a little bit of it. I don't know how it all works. Honestly, I think if you want to use it, go for it. It sounds great. How has it been working for you so far? Have you had any issues?
For the first time ever, I think we've had 0 CAN issues. We had a lot of other issues, but no CAN issues.
Yeah,
so
that's good.
And it runs it through the Ethernet, and it's just pretty robust and seems like. And you can I think you can isolate it by turning on and off resistors that are built into the thing, but just got it as a tip from somebody else, and it seemed to work out pretty good for us. I don't know how that's going to integrate into the new system core stuff, but I think it's probably still feasible.
Yeah, I think it'll certainly still work with the system core. Absolutely. I mean, the same Ethernet's there. I mean, it's kind of up to, honestly, just what you like on your robot. I'm not sure how much it all weighs. That would be kind of an edge case consideration, though, because it's such an important system. I think probably cutting off a chunk of metal would be more valuable. But yeah, I've seen it a few times. I think I may have even seen your robot with it, and that looked perfectly fine to me. It seems to work well. So.
Yep, and it's got the integrated power for encoders, or for your CTRE encoders and stuff that you can run through it. So it's got some cool little things. It's not cheap. It's super light though. You're not really adding hard.
Okay.
So.
Awesome.
Jesse, can you please repeat the name of the product and where you got it from for anyone who missed it in the intro?
Yeah, it's Swift Robotics, SWYFT, and it's the CAN Connect wiring V2. If you just type in Swift Robotics, you can look up their website, and they have a few different products out there.
Got it. And Ben has shared it in the comments as well.
Yep, cool.
I see a question from Chris K. Do you ever put electronics upside down on the bottom of your robot? What's your opinion on doing so? We have not. I think looking back on it, we should have this year. I don't think there's actually any space below our robot to do our electronics. If you take a look at our robot, almost everything is mounted vertically up in some weird spot. But even so, having accessibility under our robot would have been a huge asset for us this year. We've had a really hard time getting into your robot. I think it's great. I would say cover it. Even if you don't think anything's going to fall down or out of your robot, if there's a cover on it, absolutely mounting things under your robot would be. I mean, I've seen it work super well and be super debuggable. I'd recommend it. Yeah, we haven't personally done it though. See, Dr. B over here's got a question.
I do. I just want you to discuss. Oh, I got to take off my green sticky. Outside of the robot, there are issues with connectivity with the driver station and controllers and the Ethernet out there. Can you talk a little bit about what you can do to prevent issues when somebody's flailing around during a match with their controller to prevent that from disconnecting? Because that's honestly been a problem when we've tried to fix it.
Yeah. I've been right there. Again, I've been our team's driver for 3 years, and it is occasional that we have issues with our controllers, issues with our USB-C cables plugging into those controllers. Generally, the few things we've come down to are, one, try to unplug things as little as possible. For the most part, everything just gets left plugged in, and we try to not abuse the ports on our controllers or on the computer. So we would plug a USB-A hub into our computer, and we'd plug the USB-C cables into that. And if we ever wanted to plug in or unplug something, we would only do that at the USB hub rather than into the computer or into the controller. That just prevents those connections from getting worn down. And then if you start being like, oh, hey, something might be up, our controller did a weird thing last match, you can just replace the USB hub, replace the USB-C cable, and you're all good. Don't have to replace your favorite controller. Don't have to replace your driver station, which, oof. Definitely recommendable. And then second thing would be try not to coil your USB-C cables too tight. This is also a thing because the link port on the new Limelight system core is a USB-C cable. So try not to coil those too tight because that bending at the connector can cause damage to USB-C cables more than I've seen any other cable. Those just happen to be the ones I abuse most. So maybe it's a real thing everywhere, but coil them loose. Be kind to the cables. I'm trying to think if there's anything else we really do. Oh, we've started carrying a full extra controller with a USB-C cable plugged in, ready to go on our computer. So at the drop of a hat, if we have an issue on driver station, rather than spending the whole match being like, oh no, our controller doesn't work, we just plug another one in. And we started doing that. We've actually had another team come over and we brought our Xbox controller over to another team that was having the same issue. So even if not for yourself, it might be a good idea to just have an extra Xbox controller and cable on board. Worth it. it can save matches. So yeah, it doesn't have to be a good one. Would recommend. Any other questions from that perspective?
We have some comments in the chat about Binary Battalion used belly pan and put a piece of polycarb to cover the robot. I will say that one of the things that the GOAT, so the team from China that played with us in Duluth this year, they had I believe all of their electronics under their robot, including their battery. I will say that every time the FTA saw that robot upside down or on its side, he said he had a little minor heart attack, that they weren't going to be ready to go. And it turns out they were just changing out the battery. So it can make people a little nervous to see a robot on its side because it looks like there's a problem when in fact you might be just changing your battery. We did a battery and electronics on the bottom side of the robot for Steamworks 2017. It was a little bit of a pain because I don't know what other teams are doing to secure your belly pan, but we were, of course, bolting it in because we didn't want anything falling out during a match because we took a hard hit or drove over something. And so to need a wrench in order to change your battery was kind of a pain. It'd be nice if the battery was above the belly on top of the robot and you only had to flip it upside down if you had a wiring issue. I think that would have worked well. But there's a lot of advantages to having it on the belly pan because it's kind of, depending on the year, it can be a lot of unused space. But if you only have to tip your robot upside down to diagnose a wiring problem and you can put your battery on the top, yeah, I like that idea. I know that Robettes, I'm pretty sure Robettes this year had all of their stuff on the bottom of their robot. I think I saw that at North Star or 10K, one of those two.
Yeah. I mean, I think, to be honest, like with the belly pan, my opinion, this is not like fact, is honestly, I think it will be as good to you as it is easy to access and get inside of. Sounds like a totally valid system to me. Not one we've done. Again, sounds great. I think the challenges with putting it on the bottom is how you attach it to your frame. I'm pretty sure I've seen teams that their polycarb cover was only just Velcroed on. That makes me super nervous. I'd be very nervous to lose my belly pan cover in the middle of a match. And then if you have bolt heads on there, now your bolt heads, depending on if you're using pan head or sockets or whatever you're using, this year, that actually might get you hung up on the bump. And so you have to kind of play it by ear in terms of how your fasteners that hold that on, assuming that they're removable so that you can get to your electronics. But everything can be overcome, but those are just added issues that can come up when your belly pan simply isn't riveted onto the bottom of your robot. Mm-hmm. See a question from Daryl. Do you know what kind of Neo motor that is? We've had similar issues, and also, do you know if your Rev hardware client was reporting a sensor fault? Because I think I might know the issue you're thinking of, because we've had it this year.
Yeah, I'll just sorry, my dad's also on this call. We have had problems with Neos, just normal Neos, Neo 550s. I think those are the only two that have sensor wires. But yeah, recently, when we check them with Rev Hardware Client 2, it's been giving us some sensor issues after we fixed the wires, because we found out how to do that, which has been really nice. But they just, the actual wire just keeps getting pulled out. And I think it's just the way we have our wiring system. They're not secured down in the Spark Max as well. I'm not exactly sure. I'm not a part of the wiring team. I just know that it's been a very big problem. So.
Okay. I guess like probably longer wires. Those will probably help you out. You could also, if you have Spark Maxes, if you can move them closer to the motor to like shorten the distance the wire has to go, that'd be a good thing. Any kind of pulling at that like housing connection, that can cause you issues. I mean, even with like the stock connectors and like pre-made cables that perfectly fit into the socket, they would probably pull out if they were under tension eventually. Especially as a robot is going over bumps and being like pulled on and stretched. As rigid as it may feel, it is wiggling around, and that can just over time jimmy a cable out. If you have some solutions you could try, hot glue. I don't think that's going to be the best solution. Probably making the wires longer if you can, or getting wire longers, moving SparkMax closer. It's going to be a really good answer. Trying to think of what else. And also, if you have a lot of time and someone that's interested in doing it, you could 3D print something to hold that wire in, or just kind of clip it, because there's the connector head there, which you could hold in. Yeah, for all those sensor cables, we usually just buy them. If you're making your own, I could see how there might be issues with that. I'm not sure if you are making your own, but we usually just buy them to get around it. It's kind of cheating. If you're making your own cables, it's way cooler than just buying them. So, but that's one thing. And then another thing we've seen is, much like an untwisted CAN wire, if you have an untwisted sensor wire, electromagnetic interference can get to that wire and cause a sensor fault in that wire. So we had a Neo 2.0 data wire with it had like 6 wires, and it was running through a bundle with a bunch of power wires, and we kept getting sensor faults from it. The cable was fine. We replaced the cable, everything, sensor faults. Just twisting that cable removed a lot of those, because it balances out that electromagnetic interference that you'll see a little bit. And for some of them, we've just moved them away from any power wires, so there's none of that interference going on. I think there's a square relationship with how far away it is and how much electromagnetic interference it is. So you just move those wires a couple inches away. That's going to remove any of the electromagnetic interference. If it's a connector issue, again, just remove that strain. Maybe just buy the cable if you're really struggling. I'm not sure what else it could be. The other thing would be just trying to swap your components. The SparkMax or the Neo 2.0, those can have like permanent board damage, which can just cause some of that to happen. So swap them around. That might be a waste of your time. I would try the other things first, but it could just be that the component is bad. Look at your sticky faults or your regular faults, or just see what's happening and make sure that if there's any on there that you don't understand what they mean, I would just Google them. There are some faults that just appear on robots, and you can never get rid of them no matter what you do. But just try to make sure there's nothing sneaky going on there, because we've let that happen to us, where it's just like, oh, there's a sticky fault that was telling us something we should have dealt with a couple weeks ago. So yeah, but well, good luck with that, because those issues can be a pain.
All right. Thank you.
Daryl, I'm going to give a +1 to Luke's comment about 3D printing some type of a cap or a cover. The last time we used Neos on our swerve modules, we took a fluke hit right in the spot where that connector goes. And that was in finals match 2, I think it was. Very scary thing to try to fix in a finals match when you've got a busted connector on a Neo on your swerve module. So anything you can do to do that strain relief, like Luke said, or put a cap to protect those connectors from just taking weird damage. I mean, even just somebody dropping a wrench just right and hitting it. So those are always good tips regardless. But those little sensor connectors for the encoders on the Neos and the SparkMaxes can be tricky.
Okay. Do we have any other questions? Because otherwise I've got questions and I'll ask you. We'll do it.
Go for it.
Oh, thank you. Oh, yeah, Ben Johnson or Ben J.
Oh, hi. So we were diagnosing our CAN this afternoon and having issues with it. So there's 2 CAN buses for the robot, the drive and the non-drive. And so when you have a long, like say 10, 12 chain of CAN, what is your favorite way of trying to diagnose when you have a CAN error? Do you start unplugging wires, wiggling wires? What are your favorite techniques?
The main way we diagnose a CAN wire, first off, if it's something, I'm sure you've tried this. Just look over it first, like see if there's something obvious happening, if there's a wire outside of the robot. But then if it's not super apparent, we'll use a binary search to figure it out. So I've got a slide about this. Let me get there. Got that up. That's not super helpful. But basically, we'll go about halfway down the CAN wire, and we'll drop in a 120 ohm resistor. If the first part of the CAN bus starts working, we know, okay, the first half of that whole CAN wire is okay. Nothing's broken there. It's working just fine. If that first half of the CAN bus doesn't work, you know the issue's on the first half. And so then you go, okay, so if the issue's on the first half of the CAN bus, then like a quarter of the way along the CAN bus, you place a resistor. And then you see like, oh, is it on the left or right side of that? And using that, you can narrow down where it is. Usually if it's a really big issue, like if you're really just struggling to figure out where a CAN bus issue is, it could like some of the weird ones we've seen are going to be electromagnetic interference. If you think, do you have Krakens on that CAN wire?
Yep.
At all? One thing I would look at is the connector there. Because it splits, like the CAN wire, it splits into its green and yellow components right at that connector. At those points where it's going into the motor, it is extremely vulnerable to electromagnetic interference. So if there's a red wire and then that yellow CAN wire like nice and close to each other, that can cause issues. That was an issue we had this year. That was harder to diagnose. So make sure those have got some space if you can. Obviously, you can look for your bends and nicks. What kind of connectors are you using?
We solder all the connections, so it kind of makes it hard to throw that 120 ohm resistor in.
Yeah, it does. Good luck.
We found it, and what?
Oh, you did? Okay.
What it was that we had used zip ties to bundle the wires to the frame to take up the extra, and we think somebody pulled the zip tie too hard and damaged the CAN wire and caused a break in the CAN wire. Because as soon as
would that be inside the wire?
Yeah, the wire itself was
okay.
As soon as we disconnected at that point, it was fine, and then we reconnected, and then we reconnected the 2 sides together, and it started working.
So I'm guessing you use like normal CAN wire, not like, because we use silicone CAN wire that can do some of that bending without as much damage.
Yeah,
the normal kind then.
The normal stuff.
Yeah. So it's probably less susceptible. We've had to replace so much CAN wire because it just got cut or something, but I guess that's a trade-off. So it's definitely that sounds really fun to find. I think our greatest one from 2025 would be we had like inside a CAN coder, the yellow was touching the green just barely. Oh yeah, that was great. Yep. So
yeah, we've also had problems where the CAN wire that we use is thicker than the hole that in that CAN coder, and so trying to get every single strand into the hole, sometimes there's strands that are sticking out, or sometimes you just don't get a good solder.
Yeah. All right. Yeah. I think our solution was we just buy them with the CAN wires pre-attached. After 2025, after that 8-hour CAN hunt in 2025, I think we're done. So yeah.
Fair enough.
Soldering them's cooler, I'm gonna be honest. But yeah, I'm glad you found that. Mm-hmm. Great. All right. I've got some questions then. My first question is, and these are just kind of like to hear from other teams so you can so we can learn from each other and see, okay, what are the problems people are having? Why'd they happen? So let's just see some root causes. So I would ask everyone, what's a problem you've had with your robot? How have you fixed it? Just tell us about it. And interesting.
Luke, 2052 uses the Anderson connectors for most of our motor connections. If we can't get a run from the motor directly to the PDH, PDP, then what we'll do is we'll put Andersons on that motor, and then we'll do an extension wire. The Andersons have a place for a tiny little zip tie, so you can actually zip tie those Andersons together so that they can't come unplugged. That's something that we've had in the past where an Anderson will pull loose, and so we'll zip tie those together. We like the Anderson connectors, especially when we're using motors, prototyping, things like that. It's a lot easier to throw in an extension wire in before the robot's in its sort of final state. It also makes it a lot easier for us to swap out a motor. If we need to, we can get those Andersons on those spare motors, and they're ready to go and get popped into the robot.
Nice. Does anyone else have one? Curious. I know we've seen our robots break. So I'm curious to hear about it.
Luke, I will say that I think it might have been 2 years ago now, we did a roundtable on electronics, and the folks on the call got into a pretty heated debate about the right way to connect wires, whether that's Wagos, whether that's Andersons, whether that's soldering. It was really interesting to hear people's take on the different ways that they connected wires on their robot. I know that one of the common tips that came out of that call was that if you're using a connector, so if you're using a Wago, or if you're using anything at all, even the connectors that come with the can on the devices that you buy, you need to make sure that those connectors don't wiggle at all. So you either hot glue those to the frame, you zip tie them to the frame, you tape them to the frame, because if it's wiggling, it's putting fatigue in your wire, and eventually the ends of your wires can break off. And I know that was a big talking point when we talked about best practices for wiring when we did that call. I honestly think it was almost 2 years ago now.
Go ahead, Ben.
Speaking of Wagos, they seem like very simple connectors to use, but I have seen several instances where students have not stripped the wire long enough, and they stick the insulation into the clamping part of the Wago, and there's a either no connection or intermittent connection. So that's very important that you use this little guide on the side.
Yeah, there we go. It's hard to see, but it's right there. Yeah, for sure. Yeah, it's definitely a big thing. Look at that guide on the side. And like another thing I've seen is if you have a PDH, which uses 3 different sizes of Wagos for 3 different sizes of wire, those also have the strip length. It's just you have to go online to Rev Robotics documentation and then figure out what the exact strip length is. So we actually go there and we measure that out with a ruler just before we make each of those cuts, which seems like a lot, but worth it. So, yeah.
I think that we discovered, I was ancillary to the conversation. So from like 6 feet away, I think we discovered that strip length is different between the Rev PDH and the CTRE PDP. I think the amount of wire that you strip away is different between those 2 power distribution panels. Yeah. I could be wrong about that, but like you said, it's good to check the documentation, because we bought the PDP because we needed the extra motor slots that the PDH didn't have, and then when we were putting our wires all back in, I think we discovered that they were too long, and we had to trim them all down to work with the PDP. Okay, yeah, Kevin and Caleb are saying, yep. Okay, so Kevin and Caleb are in the shop right now working on the robot, so they're saying, yep, it's only, which I think means it's shorter.
Yeah, that's a different connector on there. Those are, I mean, it's Wego-like, but different connector. Just curious, we don't use the PDP. We use the Rev PDH, hashtag Team Rev. What do people think of the... What do people think of putting ferrules on those connectors? I've heard some debate there. So what's the... For people who've used the PDP, do you put ferrules on the ends of those or no?
I will say that has been a hot topic again in past calls to use ferrules or no ferrules, and I think it comes down to you need to have a good crimper. You need to make sure that you know what you're doing when you crimp a ferrule. I think that makes all the difference. Oh, Kevin and Caleb say in the chat, CCRE recommends against ferrules on the PDP. They recommend them on the, or you can use them on the PDH. Interesting.
All right.
Luke, one thing you haven't brought up yet is the main breaker and the battery, and how big a wire you use, and how long is that wire?
So when you said main breaker, I had a heart attack there because we created a little bit of smoke in our school because of that. So, but with the main breaker, I can always recommend tightening down the bolts on the wires you have there. As for size, I'd go as big as you can. We've looked into it. I think I've been a little bit confused, but in general, what I've gotten out of that is the bigger, the better. I think that's partially a choke point for your wire. Just get that to be as big as possible. Look at what your PDH or PDP can accommodate, and then honestly just go with the largest wire, which is the lowest gauge that you can get away with. Another thing, I think this was kind of nitpicky, but put your driving motors, or the motors you care about the most, closer to the front of your PDH or PDP, just for the maximum flow there. So, but yeah, as big as you can. I would say it's worth it. We did this, I think we did that on one of our robots. We swapped mid-year, and we noticed noticeable change and exactly how much power we could get out of things. So yeah, bigger is better. Dr. B might know more about it if he has any input.
I know this is also a hot topic of debate. I'd love to hear Brian's input on this if he's got something to share. But I think there's a camp saying the thickness of the wire is less important than the length of the wire. So the closer you can get to what you have to power is more important than the thickness of that wire. You need to fit what works for your situation. Brian, your thoughts?
Yeah, I think honestly the happy spot is AWG4. 2 is enormous and heavy. 6, we found when we did Rifts of Insanity, we were having brownouts because we used 6 throughout the whole robot, from the battery to the breaker to the PDH. And as soon as we swapped out for 4 and actually upgraded our connectors to the SB120s, which is an enormous ordeal, taking all of your chargers and all of your batteries and all your connectors and changing them from the red connector to the blue Anderson connector is expensive and very tedious, but honestly changed our world. We did way better in terms of our power management and ability to deliver the maximum amps that we needed at any one point. And actually for adult and student hands, the blue connectors are a lot easier to manage. They're not as hard to put together and take apart as a blue. They're bigger, but they actually, when they're together, are less likely to fall apart. So you're less likely to need a zip tie to put them together, which I cannot convince the students to put a zip tie into the SB 120s. But I'm very much a fan of AWG4 throughout the whole system. If you go to 2, you honestly can't get it into the PDH. And getting into the breaker, into some sort of a connector that you can crimp, is not so good. And the nuance also, even for the SB120s, and especially if you're using the little red connectors at the SB50s, getting a larger or small wire into there, you need the right kind of the little metal part that goes into your connector. There's different gauges of that metal part that either have a very thick rim or a very thin rim that when you crimp it down is the right size to make that wire fit into there. If you take a wire that's designed for AWG2 and crimp it on to an AWG4 wire, you can have this flat thing that you can't even press into your blue connector. So you've got to get the right equipment, but I honestly think 4 is the right answer. And the blue connectors changed our world, and they're easier for students and adults to manage because they're not this little tiny red thing that you're trying to take apart. So that's my 2 cents. I don't have great evidence, but I have pretty good evidence that actually changed our power. Looking at the logs before and after that change a couple of years ago, and we have honestly had very little problems with brownouts, except for that one time where we didn't swap out the battery over lunch. That was a problem, but it still ran even after not swapping out the battery after lunch. Doing your wires right and having the right gauge and doing your crimps right is a big deal.
Ryan, how long was your wire run on that Rifts of Insanity robot when you switched over?
From battery to the breaker, probably 16 inches, because our battery wires tend to be 12, and then it had a ways to go, and then it went for the PDH from the breaker probably another 6. It was not short on this current robot. From the battery connector to the PDH is like this long. How long is it, Luke? It's like the shortest connector I've ever seen.
It's just extremely fun to put together because we have to like bolt the breaker in and out to get that wire in. So
it's true. Yeah. So our runs this year are very short, not necessarily on purpose, but essentially that's where it had to be. But the short runs actually do help you. I think that's actually a big deal. And the thinner your wire is, the more that matters. If you're running very thin wire for a long distance, that's a big deal. If you've got 2 gauge wire, it hardly matters, but I don't want to add 10 pounds of wire onto my robot. That doesn't make sense.
And I think a big important lesson there to take away here is it's not just the wire, but it's also the connector. I mean, the connector is not a lot of steel there. There's not a lot of steel there in that connector. And so you can have a big, thick, ginormous cable, but if your connector is not equally as big, then, you're not getting a lot of gain out of that. As a robot inspector, I will say that a good rule of thumb tip for next year and the years to come is pay attention to where you're putting your main breaker. I had 2 teams that I inspected in Duluth who to turn off your robot if there was a problem, you had to dig through 30 balls in your hopper and stick your hand down through running and spinning belts and wheels. And of course, that was never going to pass inspection. And so the result was that they had to add wire and they had to get that main breaker outside on the edge of the robot. And of course, we all know that the longer a wire, that's not as good. So thinking ahead to not only where your battery is going to be and where your PDH is going to be, but how you're going to get that to a place where you can hit that button with your finger. That's important. It also that might be one argument against having everything on the bottom of the robot under the belly pan, because then you got to run a wire somewhere up to the top of the robot, and that could add your length. But think about that main breaker, because we've just talked about how long your wires have to be. But then if you need to extend them out to get your breaker in a spot where the inspector will pass it, you may have ended up losing all of the current advantage you had with the bigger wire.
I'll also take this moment to let people know there is an ideal direction for the breaker. This blew my mind, but yes, it does. It has a bat side and an aux side, and one of them is supposed to go to the robot and one of them is not. So there you go. The more you know.
I will say I was also surprised how many teams came with the main breaker that was pointing right towards the outside of the robot with no protection. So at least in Minnesota, the inspectors usually bring main breaker hats so that a ball or another robot's intake is super unlikely to be able to turn your robot off mid-match. So that's also a good thing. They 3D print these hats and bring them to the competition. But if you're not in Minnesota, you may not have as friendly of robot inspectors who are bringing hats to hand out. I don't remember who designed this hat. I'm confident if you look on Chief.fi, somebody will show you the hat that fits on that main breaker. We've been using one, I think, ever since the COVID years, and I don't think we've ever had a problem with it.
I've just heard a rumor that there are good breakers and bad breakers, and I'm not sure that that's true, but it sounds like there were batches of breakers with the little yellow tab that either flipped under not too much current or never flipped and started you on fire. I'm not sure that that's true, but I've heard that rumor, and I don't know how you would test for that, honestly. Put a load across this and look at the drop of resistance across it, or something else. I'm not really sure, but having a bad breaker that flips when you're under competition circumstances and you're not overloading would be terrible, and having a breaker that doesn't break when it should would also be bad.
I have heard the same rumor, Ryan, that those breakers with the yellow levers tend to trip more easily. I've also heard mentors say that once you've had a main breaker trip, don't use it again. Get yourself a new main breaker. Yeah, I don't know whether it's a bad batch or it's just that model or whatever the case may be, but I've heard similar things. Kevin and Caleb say Optifuse. I don't know what Optifuse. Oh, those are the bad ones, we think.
Yeah, that's true. But how would you test for that beforehand is the question, I guess. Is there any way of testing a breaker to see if it is a bad one before you die in the middle of the match?
Well, if the thing trips and you don't want to use it again, testing is kind of a destructive test at that point. So I don't know. This is outside of my wheelhouse of expertise, so I don't have a lot to benefit here, or to a lot of good information to share here. Like you said, sort of rumors. So I'm not sure what's real and what's not. Luke, I have a question for you as a student who's doing electronics for your team. How many students on your team are proficient in electronics, and how do you teach that? How do you train that? How do you find the students who want to become electrical experts?
Yeah, so we keep growing that number. It's kind of a work in process, making sure everyone's ready to do it. For me to learn electronics, I just kind of learned it over the summer. And then I had the opportunity to wire up a robot, and that was enough for me to learn and get started. For the average team, I think probably when you're teaching students, or you want to get new students involved in that, wiring a robot is by far the number one best thing you can get them to do. And I would say, don't just say, hey, go wire this robot. Get them started off right by learning how to do the different things, learning how the Wagos work and just how everything's connected, and then say, okay, go ahead, wire this robot. And I mean, that's the best way to learn. It's really difficult, from what I've seen, for most people to learn just by watching or just by wiring a robot. It doesn't really work out. So the only way to learn is by doing. Also, having students draw wiring diagrams is a big thing. If you can draw a wiring diagram and you know all the connectors, that's a big part of it. But yeah, just nothing replaces experience. That's one of the reasons we've started to do mini trials. So that's a huge benefit there. During mini trials, basically, I would just have them wire their robots. And then before I let them fry $100, $200 of electrical components, I'd just walk through and point out a few things that were wrong. And now we have 5-6 people who I'd say who could put things together. Some programmers. We have 2 future electronics leads on our team that are, I think, pretty ready to get into that. Coming up here, we're going to rewire our test robot FWRB, and I am going to sit in a chair with a bottle of soda and, I don't know, maybe scroll on my phone or something, and then go back and see. So definitely just hands-off electronics learning is a big thing, and just let them learn. It costs wire, it costs robot, it costs time, but it is, I think overall, when you think of how much you spend a year on a robot and getting to a match, electronics failures are much more expensive.
Do you have a dedicated electronics sub-team, or is it just a group of students on your build team that do wiring?
So last year we had a thriving electronic sub-team of me. So we're growing that this year. I'm not sure exactly how it's been in the past, but yeah, I think we're moving towards a dedicated electronic sub-team. Again, on our team, you can very much so move around and work on multiple parts, but we do have people that do dedicated electronics. And to kind of keep that running the whole year, we just like to have lots of other kind of things that they do or that we do. So wiring off-season robots, wiring test platforms or bots in a box, as we call them. All that's good experience that we do to kind of keep electronics running year round and get as much experience as we can. That's a big deal. Dr. B?
Yeah, I would actually mention that we actually literally have a bot in a box. We brought a like briefcase that looks like you're on MI5 or on some spy show that's got a Rio and a PDH and a power supply and a motor, and you can plug that in for either programming or for people learning electronics how to hook stuff up. Allowing students to actually take that home and play with that is little risky, but actually big deal, because students on their free time playing around with something outside of shop time allows them to learn at their own pace and do whatever they want to play with and do. That's actually been a big boon to our team to allow students to do that, not just in the shop, but have literally a robot in a box that they can take home and play with.
Yeah. Another thing I would add is this is before next year. I learned a whole lot about electronics, and this is unfortunate, my senior year in AP Physics 2. It was just like one short unit, and it was just the electronics unit, learning amperage, voltage, resistance, and how all of that stuff interacts. Big deal to understand. There's a lot of it's a little bit of magic. Once you do that, it all makes a lot more sense. So if you know it and you're able to teach some students that without them needing to wait for their junior or senior year to take that class, totally, I would say worth your while. Another thing I would say about the bot in a box is, yeah, especially now with the more outdated Robo Rios, maybe like if you have an older power distribution hub, it's not that much of a risk to send it home. A big concern some people have would be batteries. But if you're not running any motors out of the bot in a box, I would really encourage you to look at how the amperage of everything, because you don't really need one. I think the answer is if you want to run a motor out of that robot in a box, you need a battery. If you don't, there are lots of power supplies that will output 12 voltage or that you can step down to 12 voltage. For example, this thing, my computer is plugged into. Yeah, that's enough. That will power your limelights. That will power pretty much everything you need, and you can just plug it into the wall. So take a look at what you have. Be creative. Send students home with robots to learn about them, but also please be careful of your budget because things happen. So yeah, I think the answer is learning electronics and learning robotics is expensive. Just a tough answer, but yeah. Got another question up, unless anyone has anything. What kinds of connectors do you use on your team and why? We've heard a few things from people. If anyone else has like a connector they use and they want to like talk about it and point out the benefits and potentially drawbacks of it, I'd be happy to hear it. So I'm curious to hear. Alternatively, if you don't want to talk about connectors, I would like to hear a little bit about this funny new box I don't get to use. So if anyone has any details that.
Caleb, if you're out in the shop and you can get the mic to work on that computer, actually, no, there's no way. That computer doesn't have a mic. You'd have to pop on with your phone. Caleb is given a presentation on the Limelight System Core at Jumpstart, and he's got our best option, but unfortunately, he's going to have to join from his phone in order to be able to talk. I will say that I'm pretty sure that we have not plugged in just a regular webcam and tried the Limelight features in the System Core. I'm not even sure if they were in the initial release of the System Core. Other things that I can tell you about the System Core from what Caleb has told me is that at one point we were having loop overruns because of our two Limelight cameras that we had in the robot And I heard him say, boy, I wish we could just use the system core because, so much more processing power and we would be able to get through. Okay. So in the chat, he's saying there weren't any of the 2027 software features during our beta test. It was mostly hardware testing. Is the alpha test. So the Limelight features that supposedly will just let you use a webcam or a global shutter cam, it sounds like those weren't there. We also had a lot of problems in the alpha release with CAN. We were using AllCTRE, and I think we were running it at MRI, and I'm pretty sure at MRI we were having CAN dropouts, and we just plugged in our Canivore and just switched completely over to Canivore. I will say that we are very, very, very much looking forward to having the 5 CAN loops. I think that's awesome and amazing. I'm so glad they added it. But we really didn't get a chance to use it much during our alpha testing because we were having dropouts, and we just ended up switching over to the Canivore. We did have it running, and we had it running in the shop, but then when we were at competition, we ended up just switching over. And I don't know that Caleb would be the one that would know, but I don't remember if we switched it back or not to CAN 0 that was actually on the system core. One other difference that was in the alpha, which I'm pretty sure they fixed, is that the Robo Rio, I'm pretty sure, has a pull down resistor on the DIO and analog pins, and it was a pull up resistor. I may have those two backwards, but if you're using limit switches, you just got to reverse the logic that's in your code. If you're using like a light color sensor, light sensor, you need to make sure you connect the wire that's for a pull up or for a pull down. And we were using a sensor that had an independent wire for each of those, and it had been snipped off really short. So we had to peel back the sheathing and find that wire and rewire our sensors in order to make them work with the system core. But
actually, Scott, we used instead of using digital IO, we used analog IO.
Oh, that's what it was. We had to change our sensors, but I'm pretty sure they announced that they were going to make the DIO AIO work the way that it works on the Robo Rio. Is that right, Ben?
I believe it's fixed. I've seen two things. One was that they're going to make it so it was switchable, and one was they're going to make it so it was pull up or pull down, whichever. I don't remember. I haven't looked at the current specs, but they said they were going to address that.
Yep. So overall, I think it was a very positive experience. We did use that system core through both MRI and Mini and Rise. So we used the system core the entire off season. The issues that we had, we worked through them. I think it's going to be a good platform, and I'm looking forward to using it next year.
Mm-hmm. All right. I'm excited to watch people use it next year and hopefully come and help out a little bit with it. But yeah.
I thought of something that you had said earlier about plug up all the non-used ports on your Robo Rio, or in this case next year being the system core. We were having a weird Robo Rio problem during Crescendo, and we don't know. We figured we must have had a piece of aluminum inside the Robo Rio someplace that was causing a short. And so we had taken that Robo Rio apart, and I don't remember how many particular years that we'd used that Robo Rio, but I cleaned it out, and I think I pulled out a tablespoon of Cheeto dust and lint, carpet lint, and burlap backing from the carpet, and a few iron filings. I think it literally was a tablespoon that was in the bottom of that Robo Rio by the time we had swept it all out and everything. So if you are using a Robo Rio year after year, and again, I guess everybody will be using system core next year, but if you're using a Robo Rio as a backup or using it on another bot or off season, it's worth taking that thing apart and using a toothbrush or a paintbrush or something and brushing the circuit board off and wiping out the box. Because it is surprising how much stuff can get inside those things.
It looks all sealed, but it's not. It's not. So
Oh, well, I recently took our bumpers apart because we built a different robot for Champs. And so we had to move our mounting pins. And I couldn't believe how much lemon zest was underneath our bumper fabric. I have no idea how it got in there. I don't understand how all of these little ball particles got underneath our bumper fabric. But it was very surprising to see all these little yellow specks. So I don't know. It's like magic. It can find its way into all the little parts and all the little areas. Brian is posting a link to Harbor Freight. Oh, electronics cleaner. Yeah.
I've actually found that very useful. Actually, every time we reconnect a new battery to old cables, we'll sand them a little bit and use that. And every time we like have old things that look a little crusty, you spray that on there. It actually does a good job. There's a lot of different versions of that, but we had a Robo Rio that was super flaky that I took apart, and I think it was something in the Ethernet port that just wasn't right and blast it. It's not conductive. It is like liquid and all the goobers come off and then it dries clean as new. That's actually a great idea for anything that might have electronic cruft on it.
Yeah, I agree. I have some of that too. I'm looking at my desk because I'm pretty sure it's out someplace. But it's like WD-40, but specifically made for electronic safe. And yeah, it kind of polishes off any corrosion or anything that you might have.
We'll short it out. If you got an old record player with a crusty volume knob that sounds crunchy, you spray it in there, good as new.
That's why I have it, is because I had an amplifier that was kind of crunchy when you would change the volume, and it's exactly that reason.
Yeah, but I think it's true for all your battery connectors, you know, your SB120s, everything else. Spray them every once in a while. That's all the goop out. That's actually, we do that.
All right, Luke, we're coming up on time. Do you have one last one you want to get out of the way before we wrap it up here?
I'm trying to think what's your
it's
like
best
the end
one?
of the world's in 30 seconds, and I need
Yeah.
to tell everyone how to keep their robots safe. Use hot glue, cover your ports. Do it. It's great. I mean, it feels cheap, but anything you can do. But I guess the main thing I would say with robot wiring is just put some effort into it. Enjoy the process. Have fun. Make it clean. Spend your time, and good luck most of all. So thank you all for listening to me talk and just being here, answering questions. I appreciate that. Again, I have some contact information up there in case you have any questions for me or for 2530. But yeah, twist your wires.
Great job, Luke. For anyone listening on the podcast, the applause emojis are rolling across the screen. Excellent job. This was a great topic. We really appreciate you coming on. It's always fantastic when we have a student come on the roundtable and share their advice. For all the students that might be listening, please consider hosting a conversation. With that, so next week, our topic is going to be hosted by Kevin from Team 2052. And he's going to talk about our new process that we use for CAD, managing your CAD documents, some tips and tricks that he's adopted from a presentation that he saw at Champs last year. And we would like to invite all teams that want to come and show us your CAD. We don't think this presentation about how we structure our document outlines is going to take the entire time. So we'd love to have teams come in next week and just kind of give us an overview of the really cool things they did in their CAD document, maybe how they've organized it. So many teams are becoming so good at CAD, and I just love looking at people's robot CAD, and I don't think I'm alone. So if you would like to come on next week and you would like to share your CAD with us in 5 minutes or so, it doesn't have to be a lot. We'd love to have you join us next week for that presentation. And then after that is Champs. We're not going to have a call on the Sunday after Champs because I think for those teams that are traveling, they're going to either be catching up on homework or exhausted. So we won't be doing a call after Champs. And then I think we only have 3 calls after Champs. If I'm recalling right, we have a call put on by our regional director. I think it's about how we manage our digital assets. So team assets and how we manage those. Then I will be doing a presentation. I'm going to take that back. A nonprofit attorney that's associated with Nightcrawler, alumni parent, is going to be giving a talk about how to start a nonprofit. So if you are looking to start a booster club, for your team, and you're looking for advice on how do we file to become a nonprofit and taxes and all those things, we have an attorney who will be on, and she will be sharing some kind of tips and tricks, things you should consider. Maybe it's not a good idea to start a nonprofit. So that'll be a conversation, and I'll be sharing some things about how Nightcrawler manages our nonprofit. And then lastly, we have one open slot left. So the very last Sunday in May is currently open. So if anybody would like to take that slot, that's the last session before we break for summer break. And if no one takes that slot, then we will just end early. There's no reason for us to go 2 weeks beyond the state tournament. So if no one's available and wants to do that presentation the last weekend in May, we just simply won't do it. And we'll end a week early, and we'll reconvene in October. So, alrighty. Once again, Luke, thank you so much. Fantastic job tonight. And I hope to see everyone next week when we talk about Onshape. Have a great night, everyone.
Thanks, Scott. Thanks, Luke.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.